Okay, so today we're looking at the second part of section 5.6. We would like to be able to find the inverse of a function. These are just going to be a little more complicated than the other ones we did. We want to be able to state the domain and range of f of x. Also, we want to state the domain and range of the inverse of f of x. We also would like to be able to graph the original function and the inverse. So in this first problem, we have f of x. You should know that f of x is y. And we've got this. That's our original problem. To find the inverse, y becomes x becomes y. At this point, we're going to square both sides. I need to get the new y by itself, so x squared plus 3 equals y. I need to write this inverse as f to the negative 1 of x squared plus 3. Now, this is not our inverse, though. Here's why. Go back and look. This domain is from 3 to infinity. Graphing the function down here. We know what a radical function looks like. This is a shift to the right of 3. It's going to look like that. So the domain is 3 to infinity. The range down here is from 0 to infinity. Keeping in mind that an inverse function means x becomes y becomes x, domain becomes range, range becomes domain. So whatever the range was of this function must be the domain of this function. If I were to graph y equals x squared plus 3, that would be this parabola like this. Well, I can see that that parabola is not going to be the inverse. An inverse has to be a reflection over this line y equals x. So therefore, the function that I'm looking for should look like that. So what I would have to do to make this the inverse of that original function is to restrict it and say x must be greater than or equal to 0. That is the inverse function. The domain of this inverse function, we can see, is 0 to infinity. The range of this inverse function, looking at my graph, starts at 3, goes to infinity. Okay, but this would be the inverse function right here. Over here, finding the inverse function. This is y becomes x. This is x becomes y. Looking at my original, I have to state the domain and the range. I'm going to go ahead and graph it. I've got a parabola that opens up. And we know that it's got 1/2 in front. That's going to be a shrink of a half. So I'm going to have 0, 0. 1 is usually 1, but now it's just going to be a half. 2 is usually going to be 4, but now it's just going to be 2. And 3 is usually 9, but now it's going to be 4.5. Just kind of getting a feel for what this looks like. And so here's the way this parabola is going to look. All right, so the domain of this I can see is just 0 to infinity. The range of this is also 0 to infinity. Starts at 0, goes on up. So continuing on with finding the inverse now. I'm going to solve for this y. I'm going to multiply both sides by 2. I'm going to go ahead and switch it up like this. I always like to keep my y's on the left. Take the square root of both sides. When you take the square root, you get plus or minus the square root of 2x. But let's look at that. Radical 2x is going to look like this. Negative radical 2x is going to look like this. Keeping in mind that the inverse must be a reflection over that line y equals x. Well, the inverse then is going to look like that. It's not going to look like that. So that tells me then that all I want is the positive of this. Even though when I solve it, I truly get plus or minus, the inverse is only going to be radical 2x. I don't have to put any restriction on it because it's just going to be this top part. If I plug in 0, I get 0. If I plug in 1, the square root of 2 is about 1.4. If I plug in 2, I would get 4. Square root of 4 is 2. So here's the way it's going to look, like that. And so for my inverse function, the domain is also going to be 0 to infinity, and the range is also going to be 0 to infinity. Check it out. Domain becomes range, range becomes domain. Same thing here. Domain became range, range became domain. All right, looking at this one now. This is y, it becomes x. This is x, it becomes y. I'm going to go ahead and add 3. I'm now going to switch these two sides around. I just like to keep those y's on the left. Okay, before I go any further, I want to graph this function. This is going to be a cube root function. Cube root functions normally look like this, kind of like that S. It's a shift to the left of 1, down 3, and a vertical stretch of 2. So I'm going to go to the left 1, down 3. There's one of my points. I could just plug in some points here to find some other things. If I plug in, let's see here, what if I plug in 0? 0 plus 1 is 1, cube root of 1 is 1, times 2 is 2, minus 3. So at 0 I got negative 1. Because of that whole symmetry, if this is up 1 over 1 up 2, this would have to be over 1 down 2. And then I know that basic shape. It looks like this. Okay, so there's going to be my cube root function. All right, so now continuing on. Domain was negative infinity to infinity. Range was negative infinity to infinity. Solving, I'm going to divide by 2. Cubing both sides. I don't want to cube this out. Just leave it as it is. If I cube a cube root, I get y plus 1. This is going to be x plus 3 cubed over 8. Now I'm going to want to subtract 1. We get this.
Riley Charles, please return to the guidance office. Riley to guidance, please.
And we replace it with that f to the negative 1 of x. All right, so this is our cubic function. It's going to have a horizontal shrink of 1/8. It's shifted to the left 3 down 1. Left 3 down 1.
Jessica Hodges, please report to your room for meeting.
So now, just kind of getting a feel for what this looks like, I could plug in negative 2. Negative 2 plus 3 is 1. 1 cubed is 1. 1/8 minus 1 is like negative 7. I don't like that. Plug in 0. 0 plus 3 is 3 cubed is 27. 27 divided by 8, that is about 3.5. Minus 1 is 2.5. It's around there. So this is over 1, 2, 3, 1, 2, 3, a little bit more. 1, 2, 3, 1, 2, 3. Hold on. 1, 2, 3, 1, 2, 3, and a little bit more. Okay, and so this is going to have to go like this. It's going to come up and curve over, and come up. All right, and then just checking it out, it should look like a reflection over y equals x. So that's pretty good there. Not bad at all. Okay, as far as our domain and range of our new one goes, same thing. Negative infinity to infinity. Negative infinity to infinity. All right, so that's finding inverses. Now, last thing, and this can be really a difficult concept, so you want to watch closely. This says if f of g of x equals g of f of x, and they both equal x, then that means that f of x and g of x are inverses of one another. So we're going to determine whether these functions are inverses. So I'm trying to do f of g of x. So here's g of x. And in my x function, that's what I have to put in for x. So I'm going to have 4 times look at that. Everything stays the same. It's 4/5. This is my new x minus 1. I have to simplify this. 4 divided by 4 cancels. So now I'm going to have 5x plus 1 all over 5 minus 1. I want to see if that's going to be x. Well, 5x over 5 is just x. But 1 divided by 5 is 1/5 minus 1. No, that's not going to cancel out. So these are not inverses. On number 17, we're going to do the same thing. See if f of g of x, we want to see if that equals x. So this would be f of, here's g of x. So in this function, wherever I have an x, everything else stays the same. But in that x, I have to replace it with all of this. Okay, I finished it. Now I have to subtract 2, and I've got the 5th root, and I've got plus 6. That's what I'm going to have to simplify. Well, 2 minus 2, that's 0. If I have the 5th root of something to the 5th power, that's just going to give me what's under the radical. And then I've got the negative right there. I'm going to have to distribute that negative through. All right, so that gives me x. So it's going to be an inverse if g of f of x also gives me that x. Okay, so let's see what f of x is. Writing that whole f of x out. Here's f of x right here. I had to plug that in. Okay, so now in my g function, wherever I have an x, right there, I'm doing g of this. So g of this means the 2 stays the same plus 5th root 6 minus, but now instead of using x, I have to use all of this. So it's going to be minus a negative. Well, I have to make sure that I put that whole thing in, but it's going to be negative x minus 2 to the 5th plus 6. That whole thing has to get subtracted, so I have to be very careful with that. So now I'm going to have 2 plus the 5th root of 6, and I have to subtract this term and this term. Both terms have to get subtracted. So if I have minus a negative, this is just going to become plus x minus 2 to the 5th. And then this would be a negative times a positive, so that would be a subtract 6. Well, 6 minus 6 cancels out, and so now I have 2 plus the 5th root of x minus 2 to the 5th. Well, the 5th root of something to the 5th is just that something, so we've got 2 plus x minus 2, that's x. All right, so I got x, so yes, inverses. All right? So that's probably the most challenging part of this chapter 5, I think, is trying to find f of g of x with these complicated types of functions. But it's something you need to be able to do, and if you sit down and really focus on it, you can do it. It's just a matter of wherever you've got that g of x, take that whole thing and plug it into that x. If you're doing g of f of x, take f of x, take that whole f of x, plug it in for that x, and then simplify, and be very careful with the negatives. Here, common mistake, people get a plus there, but this is times a negative times a positive. That has to become subtraction. All right, guys, that's it. That's the last set of notes for chapter 5.